In Chem Fun today, we are going to present a very important principle in chemistry which goes under the name of Le Chatelier's principle. Now this Le Chatelier's principle deals with reactions under equilibrium. That is, when two reactants are reacting to produce products, there is a stage when the rate of the forward reaction and the rate of the backward reaction match one another, and this is known as an equilibrium reaction. Before proceeding with detailed explanation, I think it will be helpful if Sai and I do this experiment, a very simple experiment. Beautiful red colors are obtained in this, and we will have the discussion a little later on. Yeah. Sai, what do you say?
The reaction involves two very simple chemicals. One is ferric chloride, or any ferric salt for that matter, and ammonium thiocyanate. Let us add these two and see what happens. I am going to, first Ratan will add ferric chloride solution. 5% ferric chloride solution and 5% solution of ammonium thiocyanate should be perfectly okay for this experiment. So
now just observe, this is very interesting. Just observe.
See the beautiful blood red color. Now this is known as chemical blood. You know many of the magicians, what they do is they take some lime and then inject thiocyanate and ferric inside with the syringes, and then we don't know the openings anywhere, and then when you cut it, you get the beautiful red color coming out. That's how many tricks are made with chemical reactions like this. Now this blood red coloration is because of the reaction of ferric with thiocyanate to give you the beautiful ferric thiocyanate complex. In fact, it's a blood red complex coming out, and along with this complex we have ammonium chloride as one of the products. So this is an equilibrium reaction. Ratan mentioned that an equilibrium is a state in chemical reactions where the rate of the forward reaction is equal to the rate of the backward reaction. You have products as well as the reactants existing, so that it's a dynamic equilibrium. At each stage the products get converted to the reactants and vice versa. There is one particular property with all these equilibrium reactions. What happens when we try to disturb this equilibrium? That's what we'll do now, and that is what was Ratan mentioning about the Le Chatelier's principle. We'll do that experiment now.
Before we do that, we'll keep a small portion of this as a reference. So
we'll dilute that several times. We'll dilute it. That should be all right.
We'll keep this over here as a reference. Dilute this.
You can still dilute it. Oh yes. A little bit, I suppose. That is to have some dramatic changes in color. You can adjust these concentrations. I think this should be all right. Okay. Now we divide this also into three parts. Okay. Now we take this as a stock solution, add a portion of it here, keep this as reference, take the next conical flask, we'll keep this as reference here, and then take the next conical flask, add some more of the sample. Now I want Ratan to add ferric chloride to this and see what happens.
So this was one of our earlier reactants.
Yes.
So here it goes.
You see the intensity of color increasing. Now, in this particular equilibrium, ferric is one of the reactants. So what are we doing? We are trying to disturb this equilibrium. So when we disturb this equilibrium, we get more of this blood red complex formation. This is the reference. Now, we'll do the next part, that is take another conical flask and add this stock solution of the original complex. To this, Ratan will add thiocyanate and see what's going to happen.
This is thiocyanate, the other reactant.
Once again, you see the color intensity increasing. Now, the intensity of the color increases because more of complex formation is taking place and the reaction is proceeding in the forward direction. Now, the next one, we'll take another conical flask and add the same stock solution of the previous one, and to this we are going to add the product, that is ammonium chloride. A solution is taken. So I'll ask Ratan to add this ammonium chloride now.
This is a fairly concentrated solution of ammonium chloride. Again, 10% should be adequate.
Quite all right, yes.
And we will add a few drops over here and see what happens.
Now something interesting happening here. You see this, the color intensity decreases. Now compared to this reference here, in the other two cases you saw the intensity of the color increasing. Here it is, add some more, we'll see if it can go to towards almost
colorless solution.
Stop it. See, it's become almost colorless. In other words, when you are adding a product, the reaction is shifting towards the reverse direction, backward direction. This is what is the Le Chatelier's principle about. It states that when a system in equilibrium is subjected to some stress or some change in concentration, the equilibrium shifts in a direction to nullify the effect of the stress. In other words, when you increase the concentration of the reactant is decreased in this equilibrium process and more of product is formed. So also, when you add a product, the reverse reaction is favored, thereby the blood red color now fades away. So increasing the reactants would favor the forward reaction, increasing the products would favor the backward reaction. This is one of the effects of the Le Chatelier's principle. Similar studies can be made with temperature effect and so on, but here is a simple demonstration experiment to show how an equilibrium system is disturbed by changes in concentration of either the reactants or the products. The reaction taking place between ammonium thiocyanate 6NH4SCN with ferric chloride 2FeCl3 gives the ferric thiocyanate complex FeFeSCN6, the blood red complex which you saw, along with ammonium chloride, that is 6NH4Cl. Now you see that the blood red complex and the ammonium chloride are the two products, and the reactants are ferric chloride and ammonium thiocyanate. And when you add the reactants, you have increase in the blood red coloration. When you add the product, one of the products, ammonium chloride, you saw that the intensity decreased. Now Ratan will summarize this particular presentation.
Sai, when you are disturbed mentally also, you try to relieve your stress in certain ways. This is one very nice way of how the chemical reactions try to relieve the stress. So let us summarize a very simple reaction in which ferric chloride is reacting with ammonium thiocyanate to give a blood red coloration due to the formation of a complex which we have kept here. After that, we first added ferric chloride and got the color coming again. Sorry, we took a portion of this, diluted it, and then added ferric chloride. We got an intensity in the color, a deepening intensity in the color. We added the other reactant, that is ammonium thiocyanate, and again the color of the solution darkened. And finally, when we added one of the products, that is ammonium chloride, we got a reduction in the intensity, or almost it was back to colorless solution. So by doing this, what we have done is we disturbed the equilibrium, and due to which the system reacted in such a way that it wanted to relieve the stress. So this, in very simple words, is the Le Chatelier's principle, which is when an equilibrium reaction or when a reaction under equilibrium is disturbed, it reacts in such a way so as to nullify the effect of the stress. So, once again, we come to the end of this very simple presentation. Now we know where to contact us. We look forward to your suggestions, your letters and your comments. Please do write to us at Chem Fun, care of Audiovisual Research Center, Osmania University, Hyderabad 500007 AP.
Thank you.